sklearnutilsestimatorchecks. Description: the estimator-checks module in sklearn provides a set of tests to ensure that your custom estimators adhere to the sklearn API and best practices. These tests cover various aspects of estimator functionality, ensuring consistency and reliability across different estimators. Inputs: estimator. The custom estimator you want to test. This is typically a class that inherits from a sklearn base estimator class like base estimator, or one of the specific estimator classes like classifier mixin, regressor mixin, or transformer mixin. Outputs: test results. The estimator checks module runs a series of tests on your estimator and provides detailed results, indicating any failures or inconsistencies. These results help you identify potential issues with your estimator's implementation and ensure it meets the required standards for integration into sklearn pipelines and workflows. Steps: define the estimator first. You need to define your custom estimator class, ensuring it inherits from the appropriate sklearn base estimator class. Import checkestimator. Import the checkestimator function from the sklearnutilsestimatorchecks module. Run the tests. Call the checkestimator function, passing your estimator class as the argument. This will execute a series of tests to validate the estimator's functionality. Metrics: not applicable. The estimator checks module focuses on ensuring the correctness and adherence to the sklearn API rather than providing specific metrics. However, you can use the test results to indirectly evaluate the estimator's performance, such as identifying potential issues with model fitting, prediction, and other operations. Visualization plots: not applicable. The estimator checks module is primarily for testing the correctness of estimator implementation rather than visualizing its performance. You can use separate visualization techniques to analyze the performance of your estimator after validating its correctness using estimator checks. Fine-tune parameters: not applicable. The estimator checks module is not designed for parameter tuning. It focuses on validating the estimator's core functionality and API compliance, not optimizing its parameters. Uncertainty methods: not applicable. The estimator checks module focuses on the basic functionality and API compliance of the estimator rather than uncertainty quantification. You can use separate methods and techniques to analyze and quantify the uncertainty of your estimator's predictions. Challenges and fixes. Challenge 1: missing required methods. Sample use case that resulted in challenge 1: you might forget to implement the necessary method, like fit, predict, or transform in your custom estimator. Fixes to challenge 1: implement the missing methods correctly based on the requirements of the estimator type. Challenge 2: incorrect method signature. Sample use case that resulted in challenge 2: the arguments or return values of your implemented methods might not match the expected signature defined in the base estimator class. Fixes to challenge 2: review the method signature and make sure it aligns with the expected inputs and outputs defined in the base estimator class. Challenge 3: inconsistent behavior. Sample use case that resulted in challenge 3: your estimator might not behave consistently across different input scenarios or might produce unexpected results in edge cases. Fixes to challenge 3: carefully test your estimator with various inputs and edge cases. Review the code and identify any potential logic errors or inconsistencies in behavior. Challenge 4: non-standard attribute access. Sample use case that resulted in challenge 4: you might be accessing attributes of the estimator that are not standard or are not consistently defined across different estimators. Fixes to challenge 4. Use standard attributes and methods as defined in the base estimator class or in the scikit-learn documentation for the specific estimator type. Avoid creating custom or non-standard attributes. Challenge 5. Missing documentation. Sample use case that resulted in challenge 5. Your estimator lacks proper documentation, making it difficult for others to understand and use it. Fixes to challenge 5. Write clear and comprehensive documentation for your estimator, including explanations of its parameters, methods, and expected behavior. Follow the scikit-learn documentation style guidelines. Challenge 6. Unclear error handling. Sample use case that resulted in challenge 6. Your estimator might not handle errors gracefully, leading to unexpected crashes or unhelpful error messages. Fixes to challenge 6. Implement robust error handling mechanisms in your estimator to catch potential issues and raise meaningful exceptions with informative error messages. Challenge 7. Missing validation. Sample use case that resulted in challenge 7. You might have omitted input validation checks in your estimator, leading to potential data errors or unexpected behavior. Fixes to challenge 7. Implement input validation checks to ensure the data provided to your estimator is in the expected format and meets the required conditions. Challenge 8. Lack of parameter validation. Sample use case that resulted in challenge 8. You might not have validated the provided parameters for your estimator, leading to potential errors or unexpected behavior. Fixes to challenge 8. Implement validation checks for the parameters passed to your estimator to ensure they are within the expected ranges and types.